Hey, welcome back to the breadboard. It's time to upgrade my final 3D printer to Marlin 1.1.8. In the previous videos we've gone through some of the parameters and everything else. I think you should be getting the gist of it by now. So I will jump right in and get started. First thing is, this is the controller board. So let's just get rid of this screen here. And this is the TronXY X5S that the controller board comes out of. It's a Core XY. Most of the parameters are exactly the same. There's one key one that is different that we have to set, and we'll find out what that is as we go through. So here's the full view of the board. One of the key differences of this board versus the other two that we have done is the microcontroller on here is an ATmega 1284, not an ATmega 2560, so it only has 128K of flash. It's also got a lot less pins on it, as you can see here, and if we look at all of the I/O, we've got an X, a Y, as 2 Z outputs from the stepper controllers and one extruder control. We also only have 3 stops for the X minus, Y minus, and Z minus. There are no plus limit switch connections on this board, and we only have 2 temperature sensors, one for the bed and one for the hot end. We also do have the connector for an LCD though. Again, it's designed to use the standard rep discount full graphic smart controller, which all the other ones have used as well. Difference is this one has the pins configured correctly, as in these connectors are put on the right way around, so pin 1s do align. Therefore the standard display controller will work right off the bat. Now this is a 12 volt only board. It will not work on 24 volts, and one of the reasons immediately for that is it uses a linear regulator, and this would get very hot if we tried to run it on 24 volts. Also, the capacitors on here are only 25 volt rated, so if there was any discrepancies or spikes, you could possibly damage these capacitors and make the board useless as well. Anyway, we're not here about upgrading the hardware on this one. We're here so that we can upgrade the firmware. So the way that this board is programmed is through this ISP connector on here. It does not have a bootloader, so you cannot program it through the USB port. You have to use the ISP. So you need the Pololu ISP programmer or some other make that also works with the Arduino Megas, that is supported by the Arduino IDE. This board also has an SD card built onto it, so we'll still be able to turn that feature on even if the display is not used, or if the display controller does not have an SD card on it. Now, one of the downsides, just talking about upgrades for a second, is that the control chips on here are soldered directly onto the board. They're not on headers or anything, so you cannot easily change them. But fortunately, they're using the 4988 chips, not the Texas Instruments DRV 8825s. So the board doesn't suffer from salmon skin effects or anything like that, or the printer doesn't. The last two connections, or the last two connection types we've got here are the heat bed output and the hot end output, and then 2 fan connections, one which is PWM controllable and one that is just all on, or all on as long as it's powered up. And that completes the quick tour around the board. So for programming it, because it is an ATmega 1284, and because of the way that this works, we need to download the Sanguino drivers. If I just bring up the Arduino IDE, if you don't have them already loaded, if you do have them loaded, you'll see them under your boards menu. If you scroll down, you should eventually find them. In my case, it's right here, Sanguino. If you don't find them, then you need to go to Board Manager, and what you would do is you would type in Sanguino, or just start typing it, and it will come up with the Sanguino. You would just hit install. In my case, it would be removed because it's already there, and that will be it. Once that's installed, you're ready to go as far as the libraries are concerned. You will need to pick the Sanguino though. So my IDE is still showing the ATmega from the previous programming we were doing. So let's flip down to the Sanguino, and once you've done that, you also need to pick the correct processor type. So here are all the different Sanguino types that are supported, and we want the 1284p 16 megahertz. Now the next step of what we have to do is, of course, go through configuration.h. Alright, so here's the configuration.h file for the TronXY X5S, and I'm not going to go through every single parameter because I've done that twice now in the other videos. The main ones that you have to set in here, though, are the baud rate. We have to change this to 115K2. We have to set the board name to baud melz. Other custom things like the custom machine name and stuff, of course, need to be set. And the other main property that needs to be changed here is the one that tells us that we're using a, if I can find it, tells us we're using a Core XY. We have to uncomment this Core XY property. Aside from that, everything else can pretty much stay the same if you want. In the spreadsheet, I have highlighted a few other properties that I read by going into Prontoface and reading the earlier properties that I had set, or looking at the stock firmware that you can download from GearBest for the TronXY X5S, which is based on Marlin 1.1.6 dev version. So going through those, not a lot of the ones that were changed in there need to be brought forward because the stock Marlin properties will work just fine, I think, in most cases. The ones that are critical are obviously things like the bed size, the directions of travel, for the direction pins and things like that. And that's pretty much it. So we've got all of these in. So the next thing we need to do is try and compile them. Now I will quickly go and show you. I just made some changes to this spreadsheet. I've simplified a little bit. I'm almost at the point now where I can share it with you. So the first page on the spreadsheet is just about printers. So more about the hardware and some calculations for some of the properties that go into it. Defining how you're configuring the stepper motor drives and things, whether you're using microsteps and stuff like that. And then I calculate the steps per millimeters at the bottom here. The second thing I've done is I've simplified this spreadsheet with all of the properties to only include the ones that I'm actually changing from the stock parameters that come with Marlin 1.1.8. So the ones that are highlighted in orange are changed, and the columns with the orange are the ones that are the new 1.1.8 stuff. The line items that are red are ones that you really do need to go and validate because they are can be very different for every single printer. Again, I'm not going to go through everything in here, so I'll leave you to go through that if you want to. More about showing you how to upgrade this now. The previous videos, as I've said, have shown pretty much everything we need. And in future videos, if I change any other properties, I will add it in here. All right, so like before, we now just hit a test compile to make sure everything is going to work properly. So I'll do that now. I'll stop the video while it's doing it and then come back to you. Okay, so here is a classic error that you can get when you're trying to compile on a smaller microcontroller. The flash, as I said, in the ATmega 1284 is smaller than the ATmega 2560, as in it's half the size. And what's happened here is that with these features that I've turned on, I've run out of flash. It's 7K in excess of what is available. So I'm going to have to decide to take away some kind of functionality in order for this to work. Okay, done a little bit of digging around because we had issues with trying to fit everything in, and I think I found a way that we can get this to go in. I must have done it before, but I'd forgotten about it because it was way back in January, I think, when I did the first time of the TronXY X5S upgrade. So what I found was, with everything in, obviously we're using too much flash memory, so I had to kill a couple of things. So the first thing I thought about was dropping the boot screens, which take up a little bit of memory, but that really didn't do anywhere near enough. But I did notice that way down in the menu structures, if we just go backwards here a second, there is a G26. So when you've got mesh bed leveling, there is a command you can send which actually start printing a pattern on the bed. Well, you could do that from just having a GCode file that you send from Cura or putting on an SD card or something like that. You really don't, you can send it from Prontoface. You don't have to have it stored and run it from the LCD display. So, I've got safe homing turned back on. Everything else is turned back on again. I tried a whole bunch of different things to see which one would actually get it. And I could turn off, lots and lots of little things, but they really weren't adding up to enough. So I had to find something big. And the only thing that I really did find was the G26 mesh bed leveling. So within the mesh bed leveling, if I turned off mesh bed leveling completely, obviously it fits in, because that's what, I tried that and it worked just fine. But I wanted to have mesh bed leveling. Within there, we have this G26 validation pattern tool, and it prints out, it heats up the nozzle and it prints out this whole thing on the bed. So I commented it out, had everything else still left on, and lo and behold, it actually takes up 98% of the flash, so we're pretty darn near full here, but it did fit. So now I've just got to upload that and we'll go and check it out. So let me just start the upload via the programmer. Oh, before I do that, actually, one thing I didn't show you, I captured the parameters out of my existing board before I updated the firmware by using the Prontoface software right here. And it's still connected, actually. One of the significant differences as well for this processor is that you can't run at 250,000 baud easily. You have to drop it down to 115K2 for it to operate. But when you connect, you can see here, I actually had already previously updated the firmware. I just hadn't turned on all of the usual safety features that I've been talking about in the last few videos. So here they all are. Anyway, I digress. I want to show you how to program this. So we're on port 24. So let me just disconnect it from there so that the IDE will connect. Bring up the Arduino IDE. Hopefully we'll get no errors. We are at 98%, so we'll see. We now have lights flashing to say that we're uploading. So a few more moments and we should be done. Okay, we're done. We didn't get any errors. So let's go check in Prontoface. We'll connect here, set the baud rate correctly now. I had it wrong before, but it was working. But I do know that it's supposed to be unreliable if you try to run it at the full amount. Just hit connect. And there's our mesh bed leveling properties back again, which is good. Everything seems to be working as expected. We do need to do the flash clearing again like we had before on the previous printer, but that looks good. So we have all our features turned on. So now the only thing left is to put it back in the printer and give it a go. Now the last thing I need to do, now that we've found out what we can do to get this to compile and go into the MELZ controller, is to go back to my spreadsheet and update the fact that I'm changing G26 mesh validation to disabled so that we can fit it in, but my spreadsheet doesn't include that property. So I'll just bring that up, and in here under TronXY X5S 1.1.8 we'll go down to where I've got the bed leveling, mesh bed leveling, LCD bed leveling. So it should go right in here. So I'm just going to insert a space and we'll put it in. And in this case it is enabled, and that should be covered. I will go through and fill in the rest of these just so that we have it. So I will fill in the rest of the columns just to make sure it's complete. But yeah, that's the last one that needs to be done. So let's go and get the actual board put back in the printer and see how well it works. Okay, so it's all wired back together, and we just got to power it up and try it. So let's do that right now. Switching it on now. And that's not looking good. We should have a display already, but we don't. I'm not sure why. Let me just check the wiring of the LCD. Okay, I've just switched it around and still nothing. That is not good. I'm just going to hook up a computer to this and see if I'm still talking to the board through the USB interface. Be right back. Okay, so we've connected Prontoface and started up Prontoface on my screen here. You can see it now, and we're just going to connect to COM10, which is what it shows up as. So, okay, it's still showing up there. I have been playing around a little bit trying to figure out why the display wasn't working, so I turned off a few of the features again, which is why the mesh bed leveling isn't here, to see if it was running out of RAM or something, and it made no difference. As you can see, it's still coming up with a blank screen. I have tested the screens on another controller and they work just fine, so it's definitely the board itself. What I want to do though is see if the printer is still going to respond from the from the console, like if I send it some G-code commands to home and things like that. So with this all connected, let me just zoom out on the camera and we'll look at the printer, because I really want to make sure it's only the display. I mean, I might have messed up some of the settings. No, haven't messed up any of the settings, because I've tried the exact same thing on another machine and it works just fine. So I want to make sure it's not going to be any other issues, just the display. In which case I can either replace the 1284 on the board, I'll have to get one ordered in, or I literally just change the board. In this case, I'm probably just going to change the board anyway if I can't resolve this, because I want to put bed leveling and some other things on here, and I can't do that with this current controller. So anyway, let's just try using Prontoface as we have it right here. We'll do a home on all axes. I think that's the one. So we can see there it's doing its XY. It's gone in the middle because I said to do safe homing. And hopefully I haven't got things too badly adjusted. Nope. Alright, so it's done its homing no problem. So obviously the controller itself is working correctly. And you can see that we were on version 1.1.8 here. So that's homing. What else are we going to try here? Well, you're seeing the mesh bed leveling and things like that. So it looks like this basic controller is working. I'm not going to waste too much time on it without the LCD working, because I really want to be able to run these independently as well. So I know I can drive these. Let's just do Z plus on its own. So that's all working fine. PID tuning, I just got to look up the G-code for what the PID tuning parameter is. I think it's an M something. Yeah, M303. So if we issue an M303, it should start the PID parameters, and then we'll be able to go back and have a look. So right now they're set at the defaults, which is 22.2, 1.08, and 114. So let's issue the M303. Did I say 303 or something else? Yeah, 303. And what we should see is things like the temperatures start to come up on this graph here and things like that. So let's just hit enter. Auto tune start. Let's open up this temperatures and we should start seeing that. Yeah, we go. So we've got the temperature rising on the head, which is correct, of course. So you can see here, you actually don't need an LCD display for a 3D printer. In fact, my CEL Robox printer that I've had for a couple of years now, or 3 years at least, does not have any LCD display at all. You drive it from the PC, but it can still run standalone as well. You upload the GCode to it and things, and it will just run happily without the PC connected. But it has no displays at all for showing you what's going on. It relies on the PC program to control everything. And so for this printer, if we didn't have an LCD, it wouldn't be a big loss. But I really do want to have one on there because I want to be able to just control them independently. And I was planning on upgrading this anyway, so I think what I'll do, even though we'll prove that this is all working for 1.1.8, is we will put in the ramped 1.4 board. That will also allow me to put in auto bed leveling with one of the BL touches or something like that. And that will be another video. But while we're waiting, let's just see what happens with this as far as proving everything else is working. Oops. If I can make that bigger. Yep. So you can see it's starting its cycle right now. Doesn't like me to. There we go. Just want to be able to see any messages that might come up on the screen down here as well while we're running. I will speed the video up at this point so that you don't have to painfully sit through yet another one of these. Now, while this is happening, it is worth noting that even though I was able to get mesh bed leveling and a lot of those other features included even on this Sanguino-based Melzi board, it was, the flash was running to its limits, and also, we are a bit constrained on the RAM and things on this controller board anyway. Being a Core XY, there's a little bit more math involved in running this printer too. So I will, as I've said, I think a couple of times now in this video already, upgrade it to a different controller. But for now, let's just let this finish. So it's done a couple of cycles already based on there. 102. Yeah, it's going to do it, I think, a few times based on our experience with the other ones. Anyway, let's just let this run and see what we get. Just tried a couple of different settings so far. You can see the nice undulating curve as it's cycling above and below. Yep, sounds like it just finished, because I can hear the fan. It's just quietened off, so it must have took the load off. Yeah, it's just telling me to put the parameters into configuration.h. I can also save them, I think. So 20.31, 1.18, and 87.78. So if you wanted to keep those, you can either write them to flash, because I think they're part of the connection now, or sorry, the configuration that's in RAM. It's not written to flash yet though. If there is a save to flash, which we can look for up in the 500s. So save settings M500. So if we issue and M500, that would have saved the settings. And now we can issue, and we can do an M503 to report the settings. That will be useful, just to validate whether it's written. So M503, I think it still needs a reset. Yes. So it's because I reset it, it reverted back to its other parameters. But we know what they are because they're way up here. So 20.31, 1.18, and 87.78. So we can write those into RAM, into Flash if we want to. Anyway, it's not about running G-codes and everything else, which this test was. It was about upgrading the Marlin. So unfortunately, during my process of taking the board out and putting it back in again, looks like I might have messed up a couple of the pins on the Mega 1284 chip. I've never had that happen before, and I don't know why it would have happened this time. Like I said, I've tried the display, changing it, and I've also put the displays on a RAMPS 1.4 board, and the displays work perfectly fine. I've also taken this exact same code and simply changed the board type to a RAMPS 1.4 and compiled it and uploaded, and it works fine as well, which means all the libraries are okay too. So my only conclusion is that it's potentially the pins on the controller chip itself, the microcontroller, that maybe got zapped by a bit of static or something like that. Anyway, I'm not going to waste any more time on it because I do want to upgrade this anyway. So as you can see, not everything always ends the way you expect it to. So in the next video for this printer, I will be upgrading the Melzi board to a RAMPS 1.4 probably, and I'll change this display because right now the SD card reader is on the Melzi board, and so if I change that to a RAMPS, I won't have an SD card slot. So I'm going to put a different different display on here, and that will give me access to an SD card slot again. Anyway, that's it for now for this one. So that's 3 done out of 3. 1 not quite as successfully as I hoped. Normally, if you're careful with your handling of your displays and your control boards, you wouldn't normally get an issue. Now, I've never ever had an issue in messing around with hundreds of different Atmel microcontroller boards and things like that in the same way. I do treat them carefully. I try to hold them by the edges in most cases. I do have anti-static benches and things like that here too. So not sure what went on, but maybe I'll do a different video trying to fix this thing. Or I'll just use it for a printer where I don't care about having a display on it. Either way, I think we can call this, as far as the 1.1.8 is concerned, a success. And move on to the next video. Bye.